Hello, class. Well, today we're going to be talking about indirect measurement. Okay, indirect measurement is something that pops up a lot, so I thought we'd take a chance to cover it here. There's a special application of similar triangles, and that is indirect measurement. Okay, and this is, as you might think, as it sounds like, it's when you're measuring something, but you're not actually measuring that thing, you're measuring something that thing produces, usually a shadow or something like that. Okay, and this involves using three measurements that you know to determine one measurement that you don't. Okay, this is a classic problem that is frequently found on the SATs. Okay, so this is something that pops up a lot on those standardized tests. We're going to take a look at a few different examples here as we move along. Okay, so example one, a tree casts a shadow of 24 feet. A 3-foot yardstick casts a shadow of 6 feet. Set a proportion to find the height of the tree. Now, looking at these, it's saying that the tree forms a right angle with the ground and the yardstick is forming a right angle with the ground. You can assume that this angle here is also congruent. Okay, so these two triangles that are set up here are going to be similar. Okay, so these are going to be similar triangles. So if we set up our proportions, you know that 6 is to 24. Okay. Okay, we have the small one over the big one. The same as 3 is to h. Okay, so 6 and 24. Okay, these are the two corresponding sides there in the similar triangles. And 3 and h are also corresponding triangles, or corresponding sides of the similar triangles. Go ahead and look at our cross multiplication. I have 6 times h is 6h, and 3 times 24 is 72. Okay, go ahead, divide both sides by 6, and you can see here that h equals 12 feet. Okay, really not that crazy, but yet this kind of thing shows up frequently on the SATs where you have similar triangles and you're trying to find a measurement that you don't already know. Again, as you can see here, they gave you 3 measurements. 1, 2, 3 measurements, and we had to find the 4th. Let's take a look at another example. A fire hydrant 2.5 feet high casts a 5-foot shadow. How tall is a street light that casts a 26-foot shadow at the same time? So let's go ahead and draw and label a diagram for the situation. So I've got this, let's make it look something like this. Okay. There's my light. Okay. And it's got this shadow out here. It's a 26-foot shadow. Okay. And then I'll get my fire hydrant here. Let's see, I do drawing a fire hydrant. That's not terrible, I guess. Okay. Okay, we know that that is a 2.5-foot fire hydrant. And we know that its shadow here is, I'm going to erase this back a little bit. Its shadow here is 5 feet. Okay. So again, we have this h that we don't know. We have 26, we have 5, we have 2.5. So we're going to go ahead and set up our proportion again. Okay, and you can see that 5 and 26 are corresponding sides. Okay. And 2.5 and h are corresponding sides. Okay, pretty straightforward, nothing terribly fancy there. So we're going to go ahead and multiply. We have 5h. Okay, multiplying this way equals 26 times 2.5, 65. Okay, divide both sides by 5. And I get h equals 13 feet. And you know what? I feel good about that answer. You can see the fire hydrant is half the length of its shadow. So half the length of the shadow here should be 13. Yeah, that checks. That makes sense. Okay, let's take a look at a couple more examples. Okay, this is a classic SAT problem. Okay, this is a released problem for one of the SAT tests. And it says a summer camp counselor wants to find the length X in feet across the lake as represented in the sketch above. The lengths AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet, respectively. The segments AC and DE intersect at B, and angle AEB and angle CDB have the same measure. What is the value of X? Well, that's a lot of information there. So the first thing we want to do here is I'm going to go ahead and label our sides. Okay, so let's go ahead and label our sides. It says here that AB is 1,400. Okay, so AB, 1,400. EB is 700, so EB is 700. BD, whoop, see, you know what, I'm already messing up here. Let's erase, erase, erase. Got to be careful here because you missed one right here. Okay, so it says that AB is 1,800. Okay, boom, boom. EB is 1,400. That looks better. BD is 700. CD is 800. Okay, so now let's go to town. So let's set up our proportions. Now here, one of the big things you need to notice is which sides are actually in proportion to each other. So you've got this angle and this angle that are congruent. Well, you've got this angle ABE and DBC. Okay, those two angles, these are also going to be congruent because they are vertical angles. Okay, they are vertical angles. So I've got this stretch here between my angle E and ABE, okay, between the 1 hash and the 2 hash angles. And the 1 hash and 2 hash angle here is 700. So I know I have 700 is to 1,400. Ooh, I'm liking the looks of that already. Okay. I'm looking for this one here. And this is between the 1 and the unmarked. The 1 and the unmarked. And that's going to be, on the small one, the 1 and the unmarked is 800. And this is going to be X. Okay. So going ahead and multiplying, I have 700X equals 1,120,000. I'm sure you had that off the top of your head. Divide both sides by 700. And you should get X equals 1,600. And you could have saved yourself a little bit of headache. If you know that 700 to 1,400 is 1 to 2, well, 1 to 2 is going to put 1,600 down there. So you know that this is 1,600 feet. Okay. And there you go. So that's how you're going to use that's how you use similar triangles to perform indirect measurement. If you have any questions, go ahead and see me in class. Thank you.